Welcome everyone. I am Dr. Ashish Ranjan and today I am going to discuss one of the very interesting topic AC voltage gain calculation of a single ended BJT based differential amplifier. So as per the topic there is a BJT based differential amplifier. So I have already drawn the BJT based differential amplifier circuitry which is shown here. Okay, and this circuitry consists of two transistors say Q1 and Q2. So here there are two transistors say Q1 and another transistor is our Q2, and we are giving input through the transistor Q1, that is our Vi. Okay, so that's why we are saying the single ended. Okay, we are giving input through only one of the transistor Q1. Okay, so Vi and two resistors are there which is connected to the collector in of the both the transistor. Okay, so this one is also we can say the collector side. Okay, so we have to very careful about the terminal collector, and again this one is our base and this is our emitter side. Okay, a two resistor and it is connected to a supply VCC, and the both the emitter is connected to a current source, that is our I, and a negative supply voltage minus VE. Okay, so our question is we have to find the AC voltage gain. So the AC voltage gain is simply our AC voltage gain we have to find. So this one is our AC voltage gain. Okay, that is our V naught 1, the output across the collector side of the transistor 1 upon the input Vi. So this one is the DC circuitry, we can say DC voltages are there and the AC current source. So the first thing in such problem is to first we have to draw the AC equivalent circuitry of the circuit. So this one I have already draw the AC equivalent circuit. Okay, so this one is our AC. I will tell you how to draw AC equivalent circuit, okay, for the particular BJT based differential amplifier. So as we are very familiar with the fundamental NPN transistor, suppose this one is our fundamental NPN transistor, then the corresponding AC equivalent circuitry is nothing but simply this. Okay, we are not going for the R naught, that is our early effect. We are neglecting the early effect. So a simple NPN transistor can be modeled to its corresponding S equivalent like beta Re, okay, resistance between the base emitter and the current source between the collector to emitter, that is our beta IB. So that I have already draw. Okay, so the corresponding transistor Q1, the transistor Q1, that is our this, is somehow model as this. Okay, this one is our transistor Q1. Okay, and the another one is our transistor Q2. Okay, this one for the Q2. Okay, so Q1 transistor, Q2 transistor. So as we know this one, so we have to know a little bit about the how to draw the S equivalent model, so that we will discuss. Okay, and we have to finally find the V naught 1 upon Vi. So for this purpose I have already, okay, draw this one. Okay, so before that what we can see that the first thing that we have to do is that for the AC equivalent circuitry, I have already pasted here to save some time. Okay, AC equivalent circuit, for the design of AC equivalent circuit. Okay, I have already drawn, but I will tell you how to draw. Okay, for the AC equivalent circuit, first of all you have to remove the supply voltage, the VCC, to grounded. Okay, the first thing that we have to do, we have to do the VCC to ground. Okay, so we have already made the VCC to ground. Okay, so supply, and the current source, current source, that is our I, must be open circuited. Okay, open circuited, open circuited. Okay, so we have to make it open. So make it open. So now this one is the circuit. Okay, for the AC equivalent. Okay, the base is grounded here. Okay, so now what we are doing, the transistor Q1 is simply say I am saying this one is Q1. So as we know this one is the model. So Q1 for the Q1, this one is the model that we have already draw. Okay, just try to understand it. And the base in the base. Okay, this one is our base in. Base in is connected to the input. So input is there. And the collector we are taking the output. So output V01 is there. And RC we have to make it down. Okay, so RC is there. Okay, similarly for the other transistor Q2, for the another transistor Q2, say I'm seeing different color I'm taking for the Q2. Okay, Q2 this one is the model. How means the base is grounded, so I have make the base grounded here. Okay, I have make like this just, and beta RE. Okay, beta RE2 I am writing, and beta IB2. This one is our collector side. Okay, for the wait. This one we have made the collector side in that side, and this one base is grounded, and so base to emitter there is a resistance beta R2, so beta RE2 we can write, and beta IB the current between the collector to emitter. So this one is the circuit. So this one is very simple, and both the emitter in, say this one is emitter in, both the emitter is connected together, and the this one is open circuit, so no need to worry. Okay, so now this one is the circuitry. So what next? So now what we have to do, we have to find the AV, the voltage in V naught upon VI. Okay, so one thing that we can say, the V naught 1 from this circuitry. Okay, V naught 1 we can directly write, or you can also go for the first one. Okay, now I am just going to this diagram. Okay, the one, now this V naught 1 I have already drawn. So the V naught 1, that is our V naught 1 value is nothing but simply some current is flowing like this. Okay. Okay. So this one is current and resistance, but the current is flowing from the, this one is our plus or minus V naught 1. So from negative side it is going. So V naught 1 can be simply written as minus beta IB times of RC. Is it clear or not? Means I'm just highlighting this one. This one is nothing but simply this multiply by this V naught 1. Okay, V naught 1 is beta IB 1 into RC with a negative sign, because it is going from the zero voltage to like this. Okay, so simply we can understand like this. Okay, and this one is our IB1, better to write IB1. Okay, because this one is our resistance. Okay, and this voltage is 0 volt, and this one is our V naught 1, and this one is RC, and current is flowing like this, our beta IB1. Okay, so the current is beta IB1. Okay, so the current beta IB1 can be written as current is flowing from higher potential to lower. So we have to write like this, 0 minus V naught 1 upon RC. Okay, so the V naught 1 is simply our minus beta IB1 into RC. Is it okay? Very simple. The same expression I am again highlighting. Okay, see, we have to focus about this. 0 volt V naught 1, 0 volt V naught 1, and current is beta IB1. So V naught 1 is nothing but simply minus times of beta IB1 RC. Now V naught 1 with is available now. So if you find anyhow IB1 as a function of input Vi, then we can easily say the value of this gain, particular gain, this. Okay, because now we have a V naught 1 as a function of IB1. Okay, so for this purpose what we will do, if we apply, and both the thing that we have assumed that both the transistor are matched. Okay, means I am writing here Q1. Okay, I'm taking some different color so it will be more visible. Q1 and Q2 are matched. Okay, means both having similar property, matched. Okay, so we can say the base current IB1 and base current IB2 must be equal. Okay, so after that what we will do if we apply, okay, I'm showing in this one, this diagram, okay, or we can do like, oh, we can do from this also, okay. So if we apply Kirchhoff's voltage law in this loop like this, okay, so as we know, the current in this one is our IB1, and the current in this one will be IB2, okay. So if we apply Kirchhoff's voltage law, okay, so what we can write, VI minus IB1 beta RE1, and this current, so again minus IB2 beta RE2 equals to 0. Is it okay? Simple. VI minus IB1 beta RE2, and then there is no need to worry, and then again minus IB2 beta RE2. Simple KVL, by applying KVL. So what we can write, VI equals to, now IB1 equals to IB2. So can we write IB, because RE1 plus IB beta RE2, okay. And also I am assuming that RE1 equals to RE2 equals to RE, okay. So one can write VI equals to twice IB beta RE, okay. So now IB value, which is simply our VI upon twice beta RE2, okay. So IB value is now known to us, okay. Now V naught value is known to us, okay. So what we will do, we will put the value of this V naught 1 IB, sorry, we will put the value of IB1 in this equation. So what we will get, the V naught 1 equals to minus beta IB, so that is IB. IB1 is simply IB into RC. So V naught 1 equals to minus beta, and IB is VI upon twice beta RE into RC. So this beta and this beta will be cancelled out, and the value of V naught 1 upon VI, that is our gain, single inlet gain, is minus RC upon twice RE. So this one is our final result, the gain, okay. The AC voltage gain for a single input minus RC upon twice RE, okay. So this is the voltage gain calculation that we have find. Once again, for the just a division, for how we have applied the Kirchhoff's voltage law, again I am going to show you. This current is our IB1, okay, and this current is IB2, and both the transistors are matched, so we are considering IB1 IB2 same, and then after we are applying Kirchhoff's voltage law in this loop. So what we can write, simple, VI minus IB1 beta RE1 minus IB2 beta RE2 equals to 0, and taking IB1 equals to IB2 equals to IB, and RE1 RE2 I, then we have to find IB. So if we solve, okay, the same expression will come, the same expression will come, and then we have to put in the V naught 1 expression minus V naught 1, okay. Once again I have to, V naught 1 is simply minus beta IB 1 into RC. IB1 is IB. So after solving, we will get V naught 1 upon VI. Okay. So the gain, that is our V naught 1 upon this gain, I am writing here, V naught 1 upon VI is minus C, minus RC upon twice RE. So this one is the final result. So this one is the AC voltage gain calculation. The thing is that you have to very careful about the AC equivalent model for the BJT, okay, and then we have to do the a complete model, AC model for the BJT, and you have to apply the fundamental Kirchhoff's law, like Kirchhoff's voltage law here, and then we can find the overall gain for a single input. Only when one input is there, the output is minus RC upon twice RE. So this is all about this today's video or the lecture that I have covered. So next day we will go for the AC voltage gain calculation for the single inlet, no double inlet, sorry, double inlet BJT based differential amplifier. Thank you.